Hi guys, so once again we are going to solve another DP question. Today we are solving knapsack with duplicate items. So here one thing you should consider, here it is asking duplicate items. So we might have solved a knapsack 01 problem. In that case, any item you were considering for once only. Here you can consider for multiple times. So think of a scenario like you are going to buy something. If you like the thing, you can buy it multiple time, and if you don't like, you don't need to buy it again and again. It's just once now. Okay, so just let's look into the question. We'll copy val11 value, weight array, capacity, and output. Here you can see like explanation. Here has used the second element 1 with weight 1 3 times. So this will minimize the value what weight and maximize the value to reach the capacity 3. Here our goal is to maximize the profit with minimum weight. So let's just go to this part and again solve the question. Here first of all, like def function, what are the things that we are having? Array, let's just say this is val wt. Third thing was n, you say n, the length of val. So this will also be an array, and the last thing is capacity. So how do we proceed such questions? Whenever you encounter any question similar to this, you can start by selecting what are the variables. So we'll just write over here variables. What are the things that can vary? So one thing that can vary is length of this array. So length of this array is described by n. So n can vary, and another thing is like the length of this capacity, not the length, value of this capacity. It can vary, like while solving the question can go from 0 to n, whatever the value of capacity is. So again, capacity. Once you knew the variables, it's time to find a base case. So we'll be solving using recursive problem. So for every recursive problem, you need to create a base case. What will be the base case? Let's think of a scenario. If capacity, think of these two variables, what can be the value? Extremes. They can either be 0 or they can be to the extreme value. So let's just consider the base value. So lower bound of this extremes, it will be either capacity will be 0 or n will be 0. So what will happen when the capacity is 0? If capacity equals to 0, what will happen? So you have, let's say here you are having 0, so you don't have to reach anywhere. But how can you maximize the profit? There is no way of maximizing the profit right here. When the value is 0, the capacity is 0, you can't consider any element, right? So there is no way to maximize the profit. That's why here the output will be, it will return 0. Again, another thing, what if n is 0? So if n is 0, what you can do is you can there is no way you can reach the limit of capacity here, so it will also be 0. So either writing it differently, we can write or n equals to 0, return 0. Okay. So again, you might get into confusion why when capacity is 0, return is also equals to 0. While we were doing knapsack 01, when the capacity was 0, we were returning 1, because in that case we either consider it or we don't consider it. But here like we can't reach the capacity. That's the reason. Okay. So moving forward, here there might be a scenario when the weight is more than the capacity. Okay, so when the weight is more than capacity, then you can't do anything. Just write if wt, if this was a function n minus 1 is greater than capacity. So in this scenario, what will you do? You'll just have to pass the function with reducing the value of n. Function, this is val wt n minus 1 capacity. Okay, so another thing, else you might face two scenarios when you are considering the element and when you are not considering the element, right? Okay, so when you are considering the element, you have to maximize, right, profit. So return, here also you have to return, actually I forgot to mention, max of, when you are considering the element. When you are considering the element, you have to return the value. So val, let's just write it, val n minus 1 plus this function, recursive function, val wt n minus 1, and then if you're considering the value, then capacity will be subsequently reduced as well. So capacity minus what you say, wt n minus 1. Okay, this was the first one, and another scenario will be when you are not considering anything. So that will be function val wt n minus 1. One more thing. So here I am doing n minus 1. This will be scenario when you are doing 0 1 knapsack, right? You are like, this will be the weight array. You are considering this. If it is considered, you will move to considering this. But in this scenario, since we can reuse the numbers, we don't need to do this. And that's the reason we'll be sticking every time to the nth element unless we are not able to reach there. And that will be val unit n minus 1 and then capacity. So again, this will be enough. This will be like sufficient. I will show you the code, but let's just first see the tabular way of doing it. Hold on a second. So how will you do the tabular way? Let's just create this box, tabular box, bottom up approach, and here as usual we used to keep n, and here we used to keep the target capacity, whatever the value is capacity. This we used to keep 0 0, and here like everything is 0, so just we will initialize dp via 0 for blind range for this sorry, I was on a call. Okay, so dp, you initialized the dp till length again to what is say cap plus 1, this is capacity 1 plus 1, and then again for underscore in range n plus 1. N plus 1 because we are here, we are starting with 1 2 3 4, then we'll go n plus 1. Okay, 0th one is taken by the dp's initialization, and we'll move forward. So now the tricky part will be here we don't need to initialize with the base scenario because the whole array is already initialized with 0. If there was anything other than this, then we would have initialized the dp with whatever the base scenario is, but in this case we are not having anything, so we'll just move forward. Here if weight So let's just write it, the scenario. If wt n minus 1 here, so first just loop over. Sorry, for underscore I in range n plus 1, for j in range capacity plus 1. Here we'll start with 1 because the base scenario is already filled with 0. Okay, and where were we? Now we'll write the space scenario. If wt I minus 1 is greater than j, then we'll just dp I j equals to dp I minus 1 j. Else, what will you do? dp I j equals to dp I minus 1 j. This is the scenario when we are not considering, and here we have to max out because we need to maximize the value, right? And then just comma, and then here value I minus 1 because that was n minus 1 plus dp. We are not doing I minus 1, just I, because we are repetitively using the number. And in case of j, we will be subtracting the weight I minus 1. Yep. And at the very end, we have to return n, and then what's the other thing? Capacity. So this will be that much enough. Here you'll find the solution over here, and that is all. Let's head over the code. I think already. So here it was a memorization code I have written. Here I was trying in the various space scenarios and just memorized it. This part is memorization, and again this one is memorization, except that the base scenario and then the maxing out the value with value added somewhere around edges here. And this was the memorization technique, and for the dp bottom up approach, we are creating the dp here, then looping overhead, checking the base scenario, not the base scenario, but whenever weight is greater than the capacity. If it is, then we'll proceed like this, else we'll proceed try to find a max value and then return. So if you submit this, it will pass. Again, sometimes the memorization will take a bit more memory, so you might get DLE, but if you do it via the tabular format, you will be able to easily pass this question. So hopefully you liked it, and we'll meet in the next one. Thank you.